All right, great. So we'll be talking about Gen AI from a trustworthy and cost-effective solution perspective, and some of the things that Progress brings to the table here. Quick disclaimer, Progress does not produce large language models. We make them better, and so this is the disclaimer about the products that we'll be talking about. Some of them are not produced by us. Progress is a $700 million company, and we have a strong operating margin and a strong R&D budget. So you're in good hands when you start looking at Progress as a potential solution provider for you. From an architectural perspective, we span everything from infrastructure all the way to digital user experiences. And the pieces that we'll be talking about today are how semantics and multi-model databases can help your Gen AI systems perform better and help you succeed. Yesterday, I was at a Gartner webinar where they mentioned that a large majority of Gen AI projects are failing right now, and it's due to incorrect estimation of costs and risks associated with the systems. And we're here to help you address some of those issues. So a little bit about me. I've been focused on the Progress Data Platform for about 10 years. Prior to that, I was a serial entrepreneur, and I've started 10 to 12 companies, depending on how you count them. And the last startup was Apixia, where we basically took computers to med school and taught them how to figure out what's really wrong with patients based on looking at their complete patient record. Been in the AI space for more than a decade and a half and been in the big data space for about a quarter century now. This article caught my attention in April of this year. Forbes is basically saying this is the year of proprietary data and not AI. And really, it boils down to the most comprehensive and proprietary data sets that you have will give you the competitive edge over your potential competitors. And that's what we're going to be talking about here today. So I'm sure if you have done any sort of research or any sort of work here in the AI space, you will realize that this is they are wrought with problems in addition to possible potential benefits. And what I want to try to bring to the table here is the sort of take that quote from Forbes and convert it into how do we solve these problems. And really what it boils down to is your proprietary enterprise context is really king. So if you provide the right context to these things in terms of into their short-term memories, their ability to predict and inference properly goes way up. If you provide unbiased data into their context window, your ability to undo any biases that they might have had during their training increases a lot. If you provide examples of reasoning and, a very simple example is we used a JSON LD where we said, okay, this is a JSON LD, this is device shadows, and this is digital twins, and both of these mean the same thing. And we gave an example of the content as well as what they mean. We were getting much better understanding from the GenAI system based on the ability to do that. So then on the data cutoff problem, if we can provide real-time data and real-time context based on the last 10 milliseconds of uploads into the database, we can provide real-time answers to the users. Also, these Gen AI systems are what I would call very much black boxes right now. They even the people who are making them have a hard time explaining why they do what they do. But if you can wrap that sort of black box with here's all the content we gave you, and also we only want you to answer from the content and context, And here's the answer, and you can record all of that. Now, all of a sudden, you have explainability, which is really, really important in regulated environments, so that you can say, this is the reason why we made this decision. This is what we provided the Gen AI. This is the answer, and we're recording all of this information for you. Another really interesting thing about doing the recordings is that you can also shortcut frequently asked questions and not have to inference your answers over and over again, which then leads to cost savings. Finally, on the robustness side, if you limit what you feed the Gen AI based on the roles and the content that the user is allowed to see, then really, if a user tries to come in as a general purpose user and doesn't have much access to your proprietary data, it's not going to have much access to your proprietary data through the Gen AI answers either. So this is all sort of really important pieces of the puzzle for improving the potential success rate for your Gen AI projects. And just to state it another way, right? These are questions that our customers ask, but really it boils down to how can we provide our Gen AI, the Gen AIs that we're using with our proprietary business context, right? That's really what MarkLogic and Progress and Semaphore have been focused on. Um, and the answer to that in terms of a potential architecture is that we call this semantic RAG, which is not only retrieval augmented generation, but retrieval augmented generation based on understanding the intent and meaning of the user's queries and tasks. And that brings a whole load of benefits to you when you do this. But really, uh, I'm not going to read each one of these. It really boils down to we can help make your Gen AI-based solutions much more powerful and reliable and accurate and very cost-effective. So here's some real-world examples from our customers. One leading crop company increased their correct answer rate from 50% to 90%. A leading chemical company, one of the few super large ones in the US, went into production in weeks with their existing data sets. And that sort of speaks to how quickly we can get our customers up and running. And then one of the big four accounting firms tested our platform against alternatives and decided that for their law advisory service, we were their secret sauce. Uh, Interestingly enough, they are saving about $2 million a week right now using this platform that they built on top of our Progress Data platform. So, when we first started this journey early last year, we were doing what everybody else was doing, which was, hey, let's ask the Gen AI questions and see some answers and see what's working and what's not working. In fact, the second question I asked ChatGPT was completely wrong, and I'm like, oh boy, there's some potential here, but it's wrought with mines, and you gotta avoid those mines. So the first thing we did is we said, okay, these Gen AI systems have short-term memory, which is context. If we can provide the right context into that short-term memory, we can potentially avoid a lot of these landmines. And so we went with this second architecture, which was essentially like an open book exam with the ability to get to the right page. And here what we're doing is we're taking in, let's say, 1 billion enterprise documents, chopping them up into, say, 100 billion chunks of data. Why chunks? Because you don't want to be providing full documents to the Gen AI. You want to be providing the right context. Again, it boils back down to context. So the next step we said is, okay, when the user asks a question, we can use that question to figure out what is potentially the highest relevancy content here. And, out of the 100 billion chunks of data, we might pick 50. And out of those 50, we might pick the top 10 and then give that to the Gen AI, and then the Gen AI can respond to it. Right. So this helps, and it is a good step along the way, but there's still a lot of problems and a lot of probabilities of problems when you just do simple RAG, which is what essentially this is. So then we said, all right, how can we even further tighten the context? And with that, what we did is we said, all right, let's start enterprise knowledge capture and use that as part of the solution. And so both these pieces on this side of the puzzle are sort of the retrieval part, and then this is the generation part, and then you've got your answers here, right? So here again, we bring in the content, we chop it up into chunks. Based on those chunks, we now with our knowledge can categorize those chunks and say, hey, this content is about Apollo 11. This content is about Apollo 13, even if the word Apollo 11 or Apollo 13 don't show up in that chunk of data, right? So the ability to do that through your enterprise knowledge is really interesting. Then the next thing we do with that same knowledge base is the user asks a question or gives a query or a task to the GenAI. We'll take that and figure out what are the key concepts that we know about from an enterprise perspective in the user's question. And then, we might be able to, again, get those 50 top chunks, but now the relevancy of those chunks and the order in which those chunks were created is different because we have more knowledge and more understanding of the user's queries and intent. But even here, let's say those 50 top chunks have 5,000 sentences in them. We can look through our knowledge and say, out of these 5,000 sentences, really the 400 of them are really what's important to the task that the user is asking about. And so again, the whole point here is we're concentrating the effect of the context. And also through prompt engineering, we can say if you use any of this content, please provide it as a standard reference. Number one was this document, number two was that document, and so on in your answer, so that the users can verify what you've just presented to them. Finally, when the answer comes back, we can look through the answer as well and realize whether certain concepts are there. And if they're not there, we can go back and short circuit and say, GenAI, please go back and look at this context and redo your answer. Or we can even do something further like validate the answer based on a significant number of the content being in the concept space that we know about, things like that, right? So again, providing further transparency into the answer back to the user. Another thing we can do is we can do hot links back to a user graph where the users can validate both sort of the graph itself or the private documents themselves as well. So one of the key questions I get all the time is, hey, Imran, I get this, but I don't know how to start the journey along creating a knowledge capture system, right? Or creating a graph that's enterprise ready for my users and for my content and for my division or for my department even, right? So a little bit about that. So if we look at knowledge capture, right, we have that piece of the puzzle. Then we also have sort of the standard suggestion by the large GenAI providers is that, hey, you can create semantic content by creating text embedding vectors. That's all good and dandy. And we'll talk a little bit about this in a second. But let's talk a little bit about how we create this knowledge. Well, we create this knowledge typically by subject matter experts and librarians in your enterprise creating these graphs. That used to be a slow and somewhat laborious process. So the next thing we did in Semaphore is we added what we call the knowledge review tool that allows users to provide feedback and suggestions into the system. And now, recently, over the last quarter or so, we've provided the ability for the largest of the GenAI models, the ones that are the most expensive, to help these librarians and subject matter experts create the knowledge graph very rapidly. One of our subject matter experts created a legal knowledge graph of 800 concepts within like half a day's worth of work, combined with the GenAI system. On the vector side, typically you have to use the smallest of the GenAI models. This might be 100 million parameters. Here we're talking trillions of parameters, right? Or tens of trillions of parameters. And the reason why you use the smallest ones is because it costs like 2 or 3 orders of magnitude less than this does. And if you're trying to tag 100 billion chunks of data, that's going to take you a lot of time and a lot of effort. And you really can't afford to use the largest models to tag this stuff. Besides, the vectors for the largest models would be way too large, and it would be hard to compute and find relevancy for as well. So we have these two systems. If we can combine search from these two systems, we will get the best context out there for you. And that's really what Semaphore and MarkLogic do together. They really help you with that aspect. The other thing that I'll say is We've just actually filed for patents last quarter that help us figure out what is missing from this graph. And basically, what we're doing is we're watching the users. We're using the large language models to say, hey, here's the potential semantic concepts or semantic links that might be of interest to the user based on the query that they asked. And then we can check the graph and go, hey, do these already exist? If they don't, we can feed them in through the knowledge review tool without the user actually touching the knowledge review tool. So we're basically automating the user feedback system into new suggestions. And then with the subject matter experts and librarians just doing a Spotify thumbs up, thumbs down like a solution, they're much more productive. Essentially, we've created a cyborg system here for generating graphs, and we're calling this progressive graphs. The other thing that we're doing is we can also do the same thing, and because we have the ability to search for content without having to do vector search, we can pick up again, say the top 50 documents and then do relevancy reordering of that content. And what that means is if your users are only using a quarter of your content, then guess what? You only have to vectorize a quarter of your content. This could be a 4x savings in your vectorization costs. On the other hand, if the user are only using 10% of your content, you've got essentially a 10x savings in your vectorization costs. So a couple of things to note from that is human in the loop is really important because that provides reliability, repeatability, and the ability to do things in a governed contextual way. And then, like in April, this article came out, which was really, really interesting, that sort of reinforces the points that we're building into our architecture, which is if you and this is on a Stanford database where they have about 20,000 paragraphs and about a similar number of questions. And the key in the Stanford database called Squad 2 is that the question can be answered by one and only one paragraph, right? And so the ability to detect, did you get the right paragraph back, is very easy to do. And so recall rate is, did I get the right stuff back, right, for the question? And over here is sort of the how many documents did it take to find the right stuff. And if you think of like a Google search, the first page would be like about here. And a regular search will get you maybe like in the 86% range. A vector database will get you in the 87% range. And the combination of search followed by vector relevancy will get you close to 90%, right? And so Mark Logic Semaphore enables you to do this combo stuff very easily. So we're already sort of beyond what a vector database can do. And then with this progressive graph stuff, where you can start figuring out what the user's intent is and start building that in, you can get higher and higher recall rates at lower and lower retrieval rates. And so we actually have customers where we've done this together with them and proven it out. Getting back to semantic RAG, again, the summary here is we aren't just AI powered. We are powering your AI systems and making them better for your enterprise, for your users' use cases, for your subject matter experts' understanding of the world, right? So with that, I'm going to wrap up.